Okay, let's get started. So today's cafe is about expanded gamut color profiles to unlock your full color potential. That sounds really awesome like that. So we're talking about color again. Like I said before, what are we going to see? Well, first of all, what is expanded gamut in color management? Why should we do it? Why is it useful? And how can we achieve it? How can we use these expanded gamut color profiles in our production? We have done a few color cafes before. We have done one about a color origin story, about measuring colors, and about using color profiles in your environment. All three of these are on our Four Pees YouTube channel. Feel free to browse there to watch these. We're kind of building on the information we already have from those three cafes. So having seen those will definitely help you in understanding everything we're covering today. Of course, this one is also being recorded and will be added to our YouTube channel once we've edited all the mistakes out of it. So, something of a recap from the last cafe is color spaces. Color spaces are important because that's kind of what we're going on about today as well. We have on the left our device-dependent color spaces, and on the right a device-independent color space. What does this mean? Well, device-dependent color spaces are color spaces based on primaries for a device. Device-independent color spaces is a theoretical color space that can basically cover any color you can think of. Both of these are useful in their own way. So a device-dependent independent color space is, for example, an LAB color space. Device-dependent color spaces could be RGB profiles or CMYK profiles. They are basically a profile for a unique device, and that uses a number of primaries. As we know, an RGB profile uses red, blue, and green as their primaries, and a CMYK profile uses cyan, magenta, yellow, and black as the primaries. So moving to RGB is an additive color space. Light plus light equals more light. So our primaries are actually darker than our secondaries would be. Then in CMYK, so this is the color, RGB is the color space used for cameras, for screens, anything that uses light to give you an image. Then in CMYK, we have a subtractive color space. So our primaries are light colors. And when we print two light colors on top of each other, the result is a darker color. And we have four primaries in this case. We have our cyan, magenta, yellow, and our key color black that can be mixed. This is the basis we're starting off with, and how we got to this point is all explained in fairly much detail in those earlier Four Pees cafes. And we're starting to build on this. In this case, we have four primaries. So what do we do when we want to create an expanded color gamut? Well, we're going to start from these four primaries, and we're going to expand on it by adding extra colors. So I have my CMYK colors. I'm going to add an orange, a green, and a violet. And that way I have 7 primaries: cyan, magenta, yellow, black, orange, green, and violet. Why would we want to do that? Well, because of, first of all, spot colors. A whole lot of spot colors are not achievable using a standard cyan, magenta, yellow, black color space, even though they are obviously achievable using RGB, which means designers are using colors in the design of their products, in the design of their, well, yeah, anything they want to get printed that you might not be able to print. In a traditional printing concept, for example, offset, what you would do is you print CMYK, and if the client wants to use, for example, 4 Pees green as a spot color, you would just mix that ink from the Pantone primaries, create the 4 Pees green, put it in an extra print tower, and print 5 colors. You would print CMYK and our 4 Pees green for the parts that use it. That's really cool and all, because you can have a really accurate color that would not be in gamut for your CMYK color space to have your branding represented. But then once the 4-piece job is done, you're starting to print a different job for a different customer, and you basically have to clean out that tower of your press, remove the 4-piece green, mix up a new spot color for that customer, put it in the tower, and start printing with that new spot color. That means that you're losing time in between each press run where you want to use spot colors to clean your press and to mix your new colors. With expanded gamut, we're increasing the gamut of our color space, so suddenly a whole lot of these colors become in gamut, and you don't need to make special inks. They can be created using just the primaries you have. That is one big reason, and that is why expanded gamut is actually very often used in processes like Flexo, where we're talking about packaging a lot of the time. Then we have images. Why would you want expanded gamut for images? Well, again, because a whole lot of RGB colors are out of gamut for CMYK, which means a bright orange, like the one on the picture I have there, might not be reachable using our CMYK color space. So it would become a more drab brown. We don't want a drab brown as our branding imagery because we like to be using very poppy, bright colors. So we would like to reach that orange. By adding our orange primary to our CMYK process, we are able to mix a lot more colors in that range, and we will have a nice bright orange in our image. Of course, with images, you're not using one very specific ink. We can't put just a single spot orange in this file and expect all the tints of orange we have here to be created from that spot orange. So using expanded gamut gives us the possibility to mix our inks, to mix our orange with our yellow, our orange with our magenta, and create a whole bunch of colors that would create a whole range of extra image brightness. So that is the why. So let's look at a bit more detail, and I'm basically re-explaining a bunch of stuff I just said. But this is a very, very, very basic definition of what our CMY color space would cover in a gamut, right? We have our cyan, magenta, yellow primaries, and we're mixing magenta and yellow to create everything on this axis. We're mixing yellow and cyan to create everything on this axis. This isn't completely accurate. In fact, this should be more of a hexagon where the red we create with yellow and magenta ends up somewhere over here and not exactly in a triangle. Anyway, looking at a 7-color process, what we would create is something like this. So a lot more of a hexagon, where our reds, by mixing yellow and magenta, would end up somewhere over here. By adding an orange primary, we can move all the way out there, and we can create a much bigger coverage of our color space. So let's say that we have a color we want to reproduce, and it falls somewhere over there. That would be, oh, that's a shame. We can't print this in CMYK. Well, the closest match we're going to be able to make is somewhere here on the axis. We're using a relative colorimetric rendering intent or perceptual rendering intent. This color moves within gamut. We're ending up somewhere over here, and we're creating a lot less vibrant green in exchange. People are used to seeing that happen in CMYK. So that is just how it's been. And for the longest time, printers have told their customers, well, yeah, that's just how it is in the printing process. If we can't make that color happen, so this is what you're going to get. And customers were like, okay, yeah, I understand. If that's how it is, that's how it is. But modern customers aren't like that anymore. In fact, we have an anecdote for ourselves where we printed our 4-piece logo on our branded clothing. We have our t-shirts and our sweaters with the 4-piece green on it. And some who is in this meeting wasn't very happy with the green that came out. It wasn't 4-piece green. That was the first reaction we had. We looked at it and we're like, hey, that isn't 4-piece green. And the printer said exactly that. The printer was like, yeah, but that's what we're creating. That is the color we're matching. And they said, this is actually a very good representation of 4-piece green. Turns out it was about a delta E of 5 away from our color, which is not extremely dramatic, printed on like a yellow t-shirt. A delta E of 5 in that green is not like painful as hell, but it is a color difference that very major brands would not accept on their packaging, for example. You can see how we as a customer in this scenario, we're like, oh yeah, but no, we can't have this. This has to be 4-piece green. Now, if we were to print the same scenario in our 7-color environment, suddenly that green is very much within gamut. So a whole lot of colors that would not have been able to be reproduced in our CMYK color space are suddenly manageable in our 7-color color space. Now, this is not like a new concept. 7-color expanded gamut printing is not new. This has been around for a pretty long time. It's being used in a lot of packaging industries. It's being used in digital printing all the time. If you have a small office DeskJet inkjet printer, you're probably putting CMYK inked in there. Just 4 primaries are being put in that printer, and you're printing all your stuff with that. To start with, digital inkjets primaries are a lot stronger than offset primaries. So already your digital process has a larger gamut, has a bigger range than you would see in offset. But with most of the professional inkjet printers, we're not ending there. This is the ink inside my printer here at the office, which is an Epson SureColor. So if we look at the primaries here, we see we actually have 10 primaries, 11 even in this case, because we're ending up with 2 blacks. But we have 10 primaries we can use in one single image, and we can choose which black to use when we print our file. So we're ending up with a light cyan, a dark cyan, a light magenta, a dark magenta, a light black, a dark black, just one yellow, and then we have orange on the left here, green, and violet as 3 extra colors. And that's quite normal in a lot of professional inkjet applications to end up with 10 inks or sometimes even more. If we look at another very known press, it's the HP Indigo. And Indigo also is known for printing 6 or 7 colors, either adding the violet or not. So in these spaces, these color profiles are being used. This is not a very new, like, strange concept. Now that we know what it is and why we would do it, how are we going to do it? Like, what would be the method of doing that? Well, the method is always the same. Again, we already have an entire cafe on how to create color profiles. And I bet in that cafe, I already spoke about the fact that the primaries are a choice. You can decide which primaries you want to use in your color profile. Then we can measure these, and then we can start using these. Of course, as in any application that you want to do like this, you need the right tools. You need good tools that are made to handle these jobs. And in our case, for us, that would be ColorLogic as the color management tool, and Colors as being a PDF tool that is able to properly handle multicolor files. So these 2 tool sets are available to be used with these processes and can handle them very well. In fact, ColorLogic ColorAnt can help you with the creation of charts, the measuring of charts, and the optimizing of the data from those charts up to 9 colors. So we're not even limited to the 7 colors we have. We can go up to 9 colors, and you can pick your primaries. You don't have to stick to a fixed process either. You choose what you want to do. Well, Colors PDF Toolbox is able to see those separations correctly and to handle them the way they're supposed to be handled according to the PDF standards. So let's have a little bit more detail. These are kind of the steps you want to go to when you're implementing a 7-color process. And it's not like an easy thing to do. There is a lot of thinking involved. You'll need a bit of knowledge, you need a bit of experience. And like I said, you'll need the right tools to get all of this done. But they are, in fact, a series of steps we can handle. First of all is the choice of primaries. We have to decide which primaries we are going to use for our process. Why do we want to use those primaries? These choices have to be made. Then we're going to characterization. We need a press where we're going to print these primaries, and we need to measure and characterize both the press and the primaries for printing so we can use the data. We'll need to create a profile to do both the characterization and the profile creation. You're going to need a good tool. For us, that would have been ColorAnt for creating the chart and measuring the chart, and ColorLogic CoPrA to create the profile. Then when we create a profile, we're creating a translation library, a table between our 7 colors and LAP. Now that means we're converting our original file, whatever it may be, being either an RGB file, a CMYK file, or a CMYK file with spot colors, to LAB and then to our profile. That is fine, but we can go further. Since we're looking at a whole thing to control our situation, we can use device link profiles, which offer you a direct conversion between your input and your output, and as well control over how the conversion is happening. At the end and throughout the entire process, you'll have to evaluate what you're doing. You'll have to look at your results and see in what how good the results are for your process. So first off, the primaries. Again, we are not the first persons who are thinking about, oh, this might be a cool idea to improve our process. Just like with CMYK having been chosen because they're the best tools for the job, so have the multicolor processes. You can see here, we're comparing in this graph on the left, a number of Pantone colors. We have 1,873 Pantone colors that we are trying to reproduce in various ways of working. Using just CMYK, we would be able to reproduce 1,280 of them. So we're losing out on about 600, so 1/3 of our colors there that we are creating. Then we have on the right here, we have CMYK, orange, green, and blue in the pink bar. With that color combination, we have 1,533 colors. Why blue? Well, because if you look at RGB as our primaries or secondaries, it might be an interesting idea to use RGB, which are normally our secondary colors, as our extra primaries that we're using. Because then we're covering the whole spectrum, right? We have CMY, we have RGB. But you can see both using RGB, we only have 1541, and using orange, green, and blue, we only have 1533. So turning to orange, green, and violet, we have 1578 colors. So the most colors we could reach was with these primaries. Does that mean these primaries are the best primaries for your job? No, not necessarily. Everything depends on what you are doing, which colors you have to add to your gamut to get the results that you want. We are working with a customer who is trying to add gamut mostly in the bright colors. Both the orange, green, and violet are all pretty dark primaries. So by adding them, we are expanding the gamut significantly, but not necessarily in the highlights. We are not gaining a lot of space there. By using a brighter green and a brighter orange, we are able to increase the gamut extremely well in those highlights and add the vibrancy we want there instead of in the dark areas. So we changed our primaries to fit our goal. And that was a really good decision with that customer. Okay, so then we're in the practical environment. We have chosen our primaries. We have done the testing we need to do. That would basically be going through a lot of these processes. We'll have to print with different primaries, measure everything a whole bunch of times, and then look at the resulting profiles and doing some analyzation to see like, oh yeah, when we analyze all of this stuff, where are we ending up? Like, what is the resulting overlap with the Pantone colors, with the RGB profiles, with everything that I'm dealing with? You can see on the left, this is the exact screenshot I used for a 4-color chart, a small 4-color chart that we would create with ColorAnt. So in ColorLogic ColorAnt, if we say we want to create a CMYK profile and we want to print the small number of patches, it offers us by default 300 patches. That is the smallest number of patches it would give. Is that a good idea to create a profile with just that data? No, you probably want a lot more data than that, but that's a small chart. If I choose a small chart for a 7-color process, and you can see here at the top, we have our 0 to 100 cyan, magenta, yellow, black on the CMYK side. On the 7-color side, we have cyan, magenta, yellow, black, orange, green, and violet. The smallest size it offers us is 900 patches. So immediately you see a lot more data is required. And that makes sense because we have to know how all the inks interact with each other to know all the colors that can be created. If we have 4 colors, we only have to overprint each of those with each other. Since we have 7 colors, we also have to print cyan with orange, cyan with green, cyan with violet, then magenta with orange, magenta with green, magenta with violet. So you have to have a lot more colors measured. Then something that's important to note here is that it's not because we're using 7 colors that we're going to be printing 7 colors on top of each other. You can't do that because we cannot print 700% ink coverage. That no press would be able to handle that. No paper would be able to contain that much ink. So even with a 7-color process, the maximum you're going to print on top of each other is probably 3 primaries. You're going to print 3 inks on top of each other in any possible space, which means the calculation of how and when which inks are being used is a bit complicated. It also means that the number of batches is limited because I don't have to print cyan plus magenta plus orange plus green. We're never going to print those 4 colors together. So that's not a necessary patch to have. Okay, once we measure everything, we end up with something like this. This is a top view of a gamut for CMYK on the left, orange, green, violet on the right. And you can see what happens. We have our axes here, our yellow axis, magenta axis, cyan axis. On the right, we have yellow, magenta, cyan, but also to the green primary, to the orange primary, and to the violet primary. And you can see how it adds information. There is a bit more of a bulge here in the green area. There is a lot more information here in the orange, and there is a bulge here at the bottom part of the violet. Like I said, most of the boost is happening on the bottom side of the gamut, so this top view doesn't like show that very well, but I couldn't put like the 3D object in the PowerPoint. That would have made everything crash. So we're not looking specifically at how every specific angle of the gamut is increased. Believe me, it's bigger. And you can see here, we're going from a smaller shape to a bigger coverage of our gamut. Then this is just a normal profile, basically. We have a profile created for CMYK OGV. But then, like I said before, you might want to like go further beyond just having that profile. And using ColorAnt and CoPrA, you are able to first manipulate the data you're getting from your press, the data that you've measured, to improve your results. And then when you have that data exactly the way you want it in CoPrA, you can again customize the behavior of your profile that you're creating, or with that profile, create a device link profile where again you have control over how your original file will be converted to your destination color space. So there you need good tools. There we go. So there is a bunch of advantages to using a 7-color process that we've talked about, that I've talked about throughout this webinar so far. One advantage is you don't have to have these variable spot colors anymore. You don't need to print 4 Pees green on your press. You don't need to print other brand colors on your press. You can print a fixed set of 7 colors that you have characterized, that you have profiles for. So you never have to change your inks. You have just CMYK and whatever extra primaries you chose to use on your press at all times to print all the jobs. Cool, you save a whole bunch of time because you don't have to spend 20 minutes cleaning your press in between every press run. In a digital environment, of course, you wouldn't have to clean your system, but you would also be using spot colors to begin with, like the extra colors to begin with. Second big advantage, you reach a much larger color gamut. You have a lot more colors within reach of what you are printing by default. So you don't have to do special things to get special results anymore. What are some difficulties? Well, software isn't really ready for 7-color processes. If you're designing in your Adobe suite, Adobe isn't really capable of properly handling the display of a 7-color profile. Does that mean you can't have one? No, you can have multicolor profiles in your Adobe suite. So you can have your objects in your InDesign. You can have your objects in your PDFs that you're looking at from Acrobat. You can have your extra channels in your Photoshop. But it doesn't mean that what you're seeing is what you're going to get. In Photoshop, when you add extra channels, they become spot color channels in your system, and they are not necessarily displayed correctly. So they're hard to soft proof. You need special tools to be able to correctly soft proof your results that you get from a multicolor profile. Now, typically in this kind of case, we would practice late binding, which means that you keep your original profiles, your original color spaces, as far as you possibly can in your environment, and you only convert right before you put the file to press. So in that case, we would be using a ColorLogic CPRA application, the color server from ColorLogic. You would have your PDF file that you made with InDesign, whatever, with your images in there coming from Photoshop in RGB, the original color space that you made them in. You would have your spot colors that you made in InDesign, and you would create your PDF. So your PDF contains RGB, CMYK, spot colors, everything that you decided to put in your design. That PDF can go through pre-flight. There are specific pre-flight profiles available, pre-flight PDF standards available that can handle RGB, CMYK, spot colors, and even multi-channel color profiles, all completely well. If you use PDFX4, you can handle the RGBs and the spot colors together with your CMYK. If you move to PDFX5N, you can handle multi-channel profiles. So there are PDF standards for print available that can correctly handle these colors. At that point, that PDF goes into CPRA. CPRA takes the file, converts every single object in the file according to what that specific object requires, and outputs your file ready in 7 colors for your RIP, for your print. So the last step before the RIP is your CPRA, then the file is ripped, then the plates are made, or the digital file is being printed, and you're all good. Again, like I've mentioned, good tools are needed. You need the right tools for the job. Is ColorLogic and Colors the only tool? No, there are other tools on the market that can handle stuff like this, but we have experience with those tools, which is why I used these tools in all the testing I've done for this presentation so far. So what can we conclude here? Well, using multicolor, using expanded gamuts will improve your quality. If you do it right, you will reach a lot bigger gamut. You will be able to print a lot more of the spot colors in the Pantone library. And because you don't use spot colors anymore, it decreases the print cost because you don't have to waste time. Time is expensive. Your machine doesn't have to stop for cleaning between your print jobs. So there are definite pluses to using an expanded gamut profile. But there is also a negative. It increases preparation work because you need to create and have a proper multi-channel profile for your output machine. You need to have in-house knowledge on how all of this stuff works, or at least you need to have someone who can help you get everything working and set up. Once everything is set up, however, the stuff will pretty much run itself in a proper automated workflow. And special software is required to work with N-channel. You need your ColorLogic software, you need your PDF software to be able to properly manage these extra colors in your gamut. So it's not an easy, let's just check that checkbox in our current solution and we'll be printing with magic. No, like everything, there is knowledge required, there is special tools required, but the gains are real. You have a result that you can reach. As usual, the question is, what do I want to achieve? What do I need to achieve is this the process for me? You don't need, like, I'm not saying everybody should always be printing multi-channel. No, that's not what I'm saying. If that is what you want to do to reach a specific result, you can do it though. That is also what I'm saying. So that was really, really quick, actually, going through this. It was mostly a theoretical exercise. So while we're still on the conclusion slide, I would invite everyone present to basically share your opinion. Have you used multi-channel? Have you been able to work with multi-channel in your environments? What difficulties did you have? There is definitely some discussion available here because this is a subject where a lot of stuff is still being discussed, even by experts. So feel free to unmute yourself and speak up. I see we have someone coming in chat, but they're only saying my name.
Hi, Michiel.
Hi.
And this is Johan. I exactly do this in practice. What you just came up with in theory. Beside using the tools from ColorLogic, which are really excellent for exactly doing that job. I'm using also packs from hybrid software for doing the editing and the workflow stuff. So, which is, in my point of view, a really excellent tool for exactly doing this. Just one thing to mention is that beside to match the color exactly, that you have also to convince the customer to accept that you have a screened Pantone color. So
yes.
That's, I think, for some customers a no-go because they want to have the pure color and not a screened color. I think that's one.
And is the fact that they don't like it, is it the fact that you can see the dots basically, or is it like just, oh no, we want it to be pure because it's our color and we like it pure?
It's really they like to have the not to have any pollution in the color.
Yeah. Okay.
So they want just to have the pure color, especially if you go to high value products like cosmetics and stuff. So they are very picky.
Yeah. Yeah. Thanks for sharing. Like, it's nice to hear that you're exactly doing the stuff that I've been describing in this this thing.
Yeah, but also the stuff what you just mentioned. So to get the software for, I mean, you really can't use Acrobat for. I mean, yeah, it's kind of working, but it crashes all the time, and it's not really fun to use it. So, but therefore, yeah, as you just mentioned, it's also the PDF toolbox from Colors, which is really good to use for it. Even much better than Acrobat DC, and you need to do the workarounds, like for soft proofing in Photoshop. You need to have the CPRA plugin that works really very great. So you can do this stuff, but you really have to do some detours to get this. So the whole world is setting up in CMYK, but so that's how it is.
Yeah, it's actually very similar to the PDF standard stuff. I'm always surprised when we're talking to PDF like pre-flight customers, how many customers are still insistent on always using PDFX1A as the PDF standard to use for everything.
Yeah.
While that is really outdated. PDFX4 is already getting old, and still not everybody wants to use PDFX4. So the industry is very slow at adapting to the newer technologies.
Yeah, I think it's also for, I mean, going back to the multi-channel, I think it's for digital. It's, I think, a bit easier than for going for the conventional. So because what I heard so far is what pigment should they use for? So the choice of the primaries, this is exactly the point, and to get this kind of standardized. So I think that's as long as this is not available, like to getting a real standard for getting exactly the I would just at the LAB value of the what you need to have for the violet, orange, and green. I think that's going to be very hard for the conventional printers. I mean, except on Flex, so they're doing it already a lot.
Yeah. And that combined with the fact that in color software, there is a lot of competition still in everything that has to do with the maths, with how we do the conversions. None of the color management companies like ColorLogic or GMG or All1, all the big names in color management software, they are not very likely to explain to the world exactly how they do it, because their results is their selling point. So they just say, oh yeah, we can totally do it. We are very good in multicolor. Look at our results. We can cover so much Pantone. We can do this, we can do that. And nobody knows exactly how they do it. So they're all competing with each other and just saying, but our results are awesome. And that makes it difficult for people to understand what is even going on.
Yep, absolutely.
Yeah, so there is another question in chat. Brighter means lighter or more luminance. I think that is about the extra primaries that I used with the customer that I talked about earlier. So we changed our traditional orange, green, violet to a lighter green, a lighter orange. By lighter, I mean we are using a Pantone color as our mixing ink. So we decided to go with a neon orange and a neon green spot color instead of using traditional orange and green in our mix and try the chart that way. So a difficulty there that we're not entirely yet through is the ink order, because we're not talking about traditional process inks like CMYK, where for one thing, the order is pretty much fixed. People have a way of using those inks in a particular order. The inks are actually developed to be used in a particular order, so the results of those color mixes are clear. If you use extra primaries, you have to consider that the resulting color might be different if you print them in a different order. So if you print your orange, green, violet, or violet, green, orange, or any other combination of all your inks together, you might see different results. So while, of course, that is part of the standardization, if you decide to use them, CMYK, OGV, in that order, then the profile you're creating is for that result, and then the conversions you're doing are for that result. If you want to see the result of a different order, you would have to reprint your chart, remeasure your chart, create a different profile with those inks in a different order. Now, ColorLogic has a tool where you can work with the primaries and you can change the ink order, and it can do some magic maths to try and figure out what the results would be with those edited primaries. But all of that is theoretical, so it's still a good idea to actually practice and put it in practice. While using the edit primaries tool in ColorAnt is very useful to like get a good idea of what is going to happen, it's still a good idea to like in practice actually do it, measure it, and get your profile. So in this case, when I said lighter colors, I meant like if we look at our green that we traditionally have, it's a pretty dark green. We picked a very, very bright light neon green to specifically expand in that area. Yeah, so I don't have a lot of other questions in chat right now. So as usual, if you have any questions, if you want to discuss this further as well, obviously we are available. You can send us emails, you can call some. And this video is going to be on YouTube. So if you don't feel like speaking up right now and completely bashing my theory and saying that multicolor actually sucks and that it's way better to stick to traditional values, go ahead and write a long comment in our YouTube video where you explain your point of view. We like the discussion that we can get on these topics. Okay, if there is it possible to see the software? That's yeah, yes, it is. I have the software available on my laptop, but it's a difficult thing to actually show you the results of what we're creating with it. So I can show you in ColorAnt that we can create a 9-color chart. I can show you measured data that I have and how that would look in CoPrA, and then I can click create profile. But I can't show you very well like on everything else, like how everything is going to work. And having a full demo of complete ColorLogic solutions is going to take another hour and a half to go through. So I won't go into that much detail. If you want to set up like a specific demo to look at all this stuff, I'm very happy to have a demo with you to discuss your use case and to like show you specific details. but it's a little bit out of scope of the webinar right now.
Just one comment on this. So Dietmar has also very good on his YouTube channel videos and stuff. Is explaining this stuff. Excellent.
Yes, Dietmar has very good videos on a lot of functionalities on the ColorLogic YouTube channel. So if you want to see very specific ColorLogic functionality, definitely check out the ColorLogic YouTube channel. I think there is one called ColorLogic and also one called CrossX Color, their American name. So go ahead and check those out. I'm sure we can put the link to their channel in the description of like our YouTube video, stuff like that, to bridge the gap between those details. Okay, so this is not the last Four Pees Café. We are going to have more of them. So next up is actually another one that I'm hosting next week. So if you're not completely tired of hearing me talk, we have another subject next week, not about color, but about content inspection, digital proofreading. So basically comparing two versions of a file, highlighting the differences between those two versions and creating comprehensive reports, all while keeping track of the chain of custody of documents. It's a very interesting subject, but it's a different topic altogether from what we saw just now. And 2 weeks from then, so not from now, 3 weeks from now, 2 weeks from then, we have another Four Pees Café with a guest about InSoft IMP. So IMP has just released their new major version, version 12. It's a very big release. There is a lot of new cool stuff in there. It's basically a new application compared to the old version. So go ahead, check out that video as well if you're interested in InSoft and imposition. They're going to explain everything that's new compared to version 9 and how it all works. So those are the two upcoming Four Pees Cafés. As usual, all of these are going to end up on YouTube. If you register, you'll get an email that says that the video is on YouTube, so you can go watch it afterwards. And we have done about 30 or 40 of these so far. So they are all on YouTube with all the content we've covered so far. If you don't find what you're looking for, you have a subject that you think is cool enough for us to cover here that one of our people has expertise about, feel free to drop us a hint, send an email, give us a call, and we'll definitely consider adding extra subjects to our list about very specific content that people are interested in. That is why we do these cafes, to share information. So go ahead and let us know about interesting things that we have to dive into. And then I'd like to thank you all for attending. Thank you, Johan, for having a bit of a practical discussion about the stuff as well. And I hope I see you all next week in the next webinar.